Hello everyone, this is Heading Tian. In this video, let's learn chapter 12.1, sampling frequency distributions and graphs. The first definition is population. Population is the set containing all the people or objects whose property are to be described and analyzed by the data collectors. The population, for example, can be the entire school student in the college. Next definition is sample, which is a subset or subgroup of the population is needed. So that means the sample can be an individual. So maybe one student in the college, the population is entire college students. And the sample can be one student, or it can be the subgroup of the population. For example, the growth of the school. So this is a subgroup of the population. Next definition is random samples. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. For example, I want one person from my survey, or from the school. I want to do the survey. So this one is a random sample. I didn't say who is this people, who is this person, or he or she is a girl or boy. I just random choose. So each of the students has the same opportunity to be chosen from my survey. Next one is frequency distribution. Frequency distribution is a graph or data set organized to show the frequency of occurrence of each possible outcome of repeatable event observed many times. So if I have a lot of data, for example, I wanted to find how many hours does students sleep at night. So maybe I will collect maybe hundreds of thousands informations from the students, from thousands or hundreds students. And so when I see the data, I will feel very confused because that's too many information. If I convert all of these information to the graph or very clear tables, so it's easy for me to analyze these data. So let's see one example. A random sample of 30 college students is selected. Each student is asked how much time he or she spent on homework during the previous week. The following times in hours are obtained. So that means I have collected 30 data from these 30 students. So here are the data. The first student, he said 23 hours. He spent 23 hours on last week on homework. Second one spent 19 hours last week on homework. So I can reorder the data because the random sample, so the order doesn't matter. If I list the data from the smaller number to the greatest number, so that means 15, 15, 15, 15, 16, 16, 16. And then can I convert all of these data to the table? Yes, the first in the table, the first column can be hours studied. So the student who studied 15 hours, here, second column is we call the frequency. Frequency means how many times this data appears. So for the 15, it appears twice because two students said he studied 15 hours last week on homework. And next one, 16 hours. So three students, the frequency should be 3. studied 16 hours last week on homework, and 17, nobody. 18 for students. So why nobody studied for 17 hours last week? You why you don't just cross it out? Why you list 17 hours there? Because if we do the table, we need this consecutive information. That means consecutive integers in this part. So 15, next one is 16, next one is 17. Even I know the frequency is 0, but that's still the information. We must have it. Next one after 17 is 18, 19, 20, 21, 22, 23, 24, 25. Even there's no data for the hour 17, we still need to list the 17 there and give the frequency for 17 0. Okay, so if I have this frequency table, if I have frequency table, it's easy for me to see the data. So I see maybe 5 people studied 22 hours last week on the homework. So we can analyze this data. Okay, next part, a frequency distribution that lists all possible data items can be quite cumbersome when there are many such items. For example, consider the following data items. These are statistics test scores for a class 40 students. If you use the previous way, so we list the score on the left-hand side. Maybe I put score. And then put the frequency here. So the score, I will start from the lowest score. Maybe I just find from my data here. Maybe 43 is the lowest score. So from 43, so 44, 45, it's 45, and continue. I will make a very, very long table. So the greatest number is 94. If it's 94, so I'm going to have a very long table and the frequency for 43, and at least maybe it's 1, and then I will have a very long distribution table. So how about to make them into the group? So there are so many data items. One way to organize these data so that the results are more meaningful is to arrange the grades into groups or classes. Yeah, we can make the grades into the classes. So what kind of classes? Maybe from 40 to 49, and then from 50 to 59, and then find how many people in this class. So use the classes 40 to 49, 50 to 59, 60 to 69, and then and so on. Last class is 90 to 99. Construct a grouped frequency distribution for 40 test score. So when we are building this kind of table, we can have a tally part here, because if we have 1, 2, 3, 4, 5, 6 classes, and then we go back to see the data here, and then find how many people has the grade between 40 to 49, and then by counting the if I see the people it's between this score, I can have 1. If I found second one, I got another straight line, and then finally I find the 3 people is in this class. And next class, let's see how many people people's score is between 50 to 59, and then from here I found there are 6 students, so frequency part is 6. and so on. I find all of the frequency for these classes. So after finding this information, I can delete the tally part, convert it to the frequency table. So what is the total? I add the frequency together equals 40, because 3 plus 6 plus 6 plus 11 plus 9 plus 5 is 40. 40 is the sum of frequency. It's the number of data items. In this question, data items is 40 students. That means there are 40 students here. I'm sorry. Let's see two definition. The first one, lower class limit. Lower class limit is the leftmost number in each class of the group frequency distribution. For example, for the first class, the lower class limit is 40. That's the leftmost number. Another definition, upper class limit. So for example, for this class, the upper class limit is the rightmost number. So let's see this this class, the rightmost number is 79. So 79 is the upper class limit for the class, the fourth class. Next definition is class weights. How to find the class weights? Class weights, we can use the difference between any two consecutive. So between any two consecutive lower class limit. So consecutive means the class next to each other. So if the consecutive classes, that's first and second classes. So the difference between any two consecutive lower class limit, that means 50 minus 40. And also I can use the second and third. So second, third, that's consecutive classes. I use 60 minus 40, 50. So I all get 10. So each class width is 10. You can also think it in this way. So that means how many numbers in each class. So the first class is from 40 to 49. So 40 and 49, they are included in these classes. So it could be 40, could be 41, 42, 43, 44, 45, 46, 40, 47, 48, 49. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there are 10. That means the class width is 10. But in this way, you need to list all of these numbers. Since this is a small small class width. For example, if I have the class is from 400 to 699. So do you need to list all of these numbers? No, you just use the difference between any two consecutive lower class limits to find the weights. You don't need to list all of these numbers in the class. Okay, let's see. When setting up class limits, each class with the possible exceptions of first or last should have the same weights. Oh yes, they just tell you each class has the same class weights. Because each data item must fall into the exactly one class. Yes, you can't have a data fall into different classes. It is sometimes helpful to vary the data, vary the width of the first or last class to allow for items that fall far above or below most of the data. Here are 3 small questions. Identify the lower limit of the fifth class. Which is the fifth class? 1, 2, 3, 4, 5. So this one, fifth class, is asking about lower limit. That's 80, because that's the leftmost number. So 80. And the next one, identify the upper limit of the third class. So this is third class. Upper limit is 69. That's the rightmost number in this class. Next one is the amount of data. What is the meaning of amount of data? That's the sum of frequency. You just add 3, 6, 6, 11, 9, 5 together, and that's the number of the data items. So that's the amount of data. We have 40. That also means we have 40 students in this distribution list. Okay, let's move on. The histograms and the frequency polygons. A bar graph with bars that can use to visualize, display the data. Such a graph is called histogram. The heights of the bar represent the frequencies of the data value. And what's the meaning? We can use the frequency table, the table we have learned, but we can also convert the table to the histogram, the bar graphs. From a bar graph, you can see the data maybe more easily, sometimes analyze the data more easily. So how to make the histogram? For example, we can make XY axis. The X axis, this is X, can represent hours you studied per day. For example, I asked my student, how many hours do you study each day? Maybe students said 0 hour, I don't study. Maybe some of them, they say 2 hours, maybe 4 hours, 8 hours, or 10 hours a day. And then these are the informations, just like the data in our in the table here, this column. And then the y-axis represent the frequency. So maybe 0, maybe one student said, I don't study. And then my bar is just has a y value 1, because one student said doesn't study at all. And study 2 hours, maybe 3 students said I studied 3 hours. So the frequency on the y-axis is 3, and 4 hours more students studies 3 hours. For example, 6 students. So the y-axis represents the frequency. And then if more frequency, that means more students in the survey said they study so 4 hours, maybe 8 hours, the 6 hours missing, it doesn't matter. This height and then this height. So you will see the bar graph, the histogram, and from the histogram you will see, oh, this class, 4 hours class, has most students. Okay, let's see, what is a frequency polygon? Frequency polygon is the line graph of class frequency plotted against the class midpoint. That means if I have a histogram and then use another color, red, on the top of each bar, the midpoint of each bar here, so the top of each bar and the midpoint, 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 midpoint. And then I line them up. This is the frequency polygon. So it's also a way to express, to display the data for you. So if you see, you have the histogram, you can create the frequency polygon. If you have the frequency polygon, you can also make the convert it to the histograms. Okay, let's see the example. Students were asked, how stressed have you been in the last week? On a scale of 0 to 10, with 0 being not all, with 0 being not at all stressed, and 10 being as stressed as possible. The students' responses are shown in the frequency distribution now below. It's in the table. Construct a histogram and the frequency polygon for the data. In the homework, you don't need to construct the histogram. You just need to select which is the corresponding histogram or the polygon, the frequency polygon. You don't need to draw it. Just identify which is the correct one. So before we have learned a little bit about the frequency table. So here maybe I put a stress rating. I put as R represents stress rating from 0, 1 to 10. And then here is the frequency. And then this table, just move this on the first row, the frequency on the second row. So it's the same thing. So from the table, you will see, so stress rating 0, we have 1 student. The stress is 1, the level is 1, there's 1 student. For example, if they feel the stress is 7, and there are 22 students. I see the table, I think more student more students are stressful because more data are on this side. Okay, how to convert it to the histogram? So I mentioned that the x-axis, I said this is x, I can list the stress reading for 0 and 1 student. So the y-axis, that's the frequency axis. So 1 student. So my bar is this height. And then for the rating is 1, the bar is this height because 1 student said the stress reading is 1. And then for 3, 4, 5, and they matched to the different frequencies. And then I got my histogram. And how to convert histogram to the frequency polygon. So we just define the midpoint here, midpoint on the top of the bar graph, the bar, and then line them up. So this one is a straight line. And then go up, go down, go down, go up, go down, like this. So, and later we delete the bars. We will have this kind of frequency polygon graph. Okay, next method is stem and leaf plot. What's the meaning of this? So if I have a plant, if I have a plant, this is a plant, this is stem, and the stem has maybe branches, or I say leaves. For example, these are leaves. My bad drawing. And if I have a lot of data, and I can list, so it's 2 digits later. For example, I have 45. So 40, that's a 10th digit. 5 is a unit digit. So in the stem and leaf plots, this method, I list the 10th digit on the stem part. For example, from the smaller number to the bigger number, I have, I can't have 0, I can have 1. 1, 2, 3, 4, 5. And make it pretty. 1, 2, 3, 4, 5 is here. 5. And each of them has their leaves. So 1 has a leaf here. 2 has a leaf here. And 3 has a leaf here. 5 has a leaf here. And what's on the leaf? Should be the unit digit numbers. For example, I have a lot of numbers like 11, 12, 19, and 21, 24, 24, and 32, 39, and 40, 45, and 52. That means the digit part, I can list them on the leaf. That means the leaf here is a digit unit digit. So if Y represents the tens, so the leaf represent the unit digit. The unit digit for 11 is 1. I put 1 here. Unit digit for 12 is 2. I put 2. Unit digit for 19 is 9. Oh, my leaf has 1, 2, 9. How about the 2? So, for example, this is the leaf. So for the 2, the 10th digit is 2. And for 21, the unit digit is 1. So I have 1. And for 24, the unit digit is 4. So I have 4. And for 3 only have 32. So 2. So for, not only 132, I have 39. So I have a 9 here. So for 4, stem is 4. So unit digit is 5. And for 50, 52. So unit digit on the leaf is 2. So I use this method. I create a plant or stem and the leaves. So I can also make the graph to the table. So let's see the example here. Use the data showing statistics test score for 40 students to construct a stem and a leaf plot. So I have 40 data here. And then I can use stem leaves table. So the first part is stem, that's the 10th digit. The second part is leaves, that's the unit digit. Let's see, we have 80 something, 40 something, 70 something, 60 something, 50, 80, 60. And then I conclude that the stem can be 4, 5, 6, 7, 8, 9. And so for the 10th digit is 4. First one I find 47. Second one, let me see. 45, 43. So I can put the unit digit here, 753. That represents 47, 45, 43. Next one is 50. So let's find 50. So we have 57, 54, 57, 59, 56. So I can put the unit digit here, 7746709. Even we have 27, that's 57. That's also represent two daters. So you can't say they are same. Can I delete one? No, you keep all the information because that's represent different people's score. They got 57, 57. Okay, so for 60, we have the unit digits like this. So we have 64, 63, 68, 66, 67, 69, 66, sorry, 66. You don't need to worry about the order. Maybe some students said, can I rearrange it? I put for 63, 3 in front, 4 on the second place. Yes, you can do that. Don't delete any information, but the order doesn't matter. Okay, next one, 70. You see 70, the people who got the score between 70 to 79 has most people. You see 75, 76, 77, 79, 75, 73, 76. 74, 78, 71, 76. How many people? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 students got the score in the 70 something. Okay, this is a way we call the stem and the leaf plot. Let's see next example. The histogram to the right shows the starting salary rounded to the nearest $1,000 for for college graduates based on random sample of recent graduates. Determine whether the following statement is true or false. The first statement said more college graduates had a starting salary in 51,000 to 55,000 range than in the 36,000 to 40,000 range. So let's see the graph here. So on the x-axis, that represents the classes. So the first classes is from 31,000 to 35,000 because the question said around to the nearest $1,000. Even we see this is 31, but that represents 31,000. So first class represents 31,000 to 35,000 salary for the new graduates. And the next class is 36 to 40,000, and then next class. So let's see. How about the y-axis? This axis represent what? Yes, that represents the frequency. So that means, for example, first class, the graduates got 31 to 35,000 dollars, and there are about maybe 70 people said their salary is in this range. And then, for example, for the people in this class, so people got 41 to 45,000 dollars. There are about maybe 720 or 710 graduates said they will get this amount of money. Okay, let's see the statement. More students, more college graduates had starting salary in this class. That's the 51 to 50,000 range. So more people in this range than the people in this range, 36 to 40. So 36 to 40,000 range. So these compare the frequency of these two classes. If they have the high or taller, higher bar, that means they have more frequency, more people. So we see this one is this height, So that means this class has more people, but the statement says the 51,000 to 55,000 range has more. The range has more people than 36,000 to 40,000. So this statement is false. We put F there. And next one, another statement. The graph is based on a sample of approximately 500 people. What's the meaning of that? That means, what's the total amount? That means I need to add the frequency together, and then we know the sample approximately how many people. So if I add the frequency people together, so for this bar, it's about 310, for example. And for this bar, it's about 275 people. So I can continue to find the frequency of these bars. If I add them together, I'm sure I will get a number that is greater than 500. So the amount of people must be more than 500 because I add these two items together, it's more than 500. That means this is false. The true statement can be is more than 500 people. So this is also a false statement. That's about chapter 12.1. If you have any question, please ask me, email me. Okay, have a good one.